Hey, Denell High School AP Physics. This is the last installment of Fluid Mechanics. This is 6.3 Bernoulli's Principle, and if you've ever wondered how to fly, I believe I can fly. You want to know Bernoulli's Principle because this is how we fly. So let's get going. First, we want to talk about the volume rate of flow. You see that word volume? It means volume. You see that word rate. What does rate always mean? Is per seconds, right? The volume rate of flow. And so the equation for the volume rate of flow is the amount of volume per second, right? The amount of volume divided by the time in seconds. Or we can say it's area times velocity. Area times velocity. And why is it area times velocity? Because area times meters per second, okay, gives you volume divided by seconds. And of course, for area, we can use the pi r squared if we're talking about a faucet, like the little picture on the right. Pi r squared times my velocity, because that would be my area. And so my units for volume rate of flow would be in meters cubed, because that's units for volume, divided by seconds, of course. Okay? So that's volume rate of flow. Now, we have this thing called the continuity equation, and what the continuity equation is whenever we have like pipes that change sizes, okay, from one size, from one area or one radius to another area or another radius, the velocity of the fluid changes as well. You can see these lines in this picture right here. The lines get closer together, so the velocity actually increases. Okay, the smaller the radius, the faster the velocity. Just try this on your little brother, or little sister. Just say, "Man, I gotta take a look at some physics." Take them out to the hose outside and have the water just flowing out of the hose, and then put your finger over and change that radius of that hose and spray your little brother or sister. It's pretty fun. Okay, and so here we can use the volume rate of flow at one point is equal to the volume rate of flow at the other point. It's conserved. Okay, and so something you'll see is Bernoulli's equation, it's all about conservation here. It's all about conservation. And so that means the area times the velocity, A1V1 equals A2V2. Anytime you have pipes changing, guys, use A1V1 equals A2V2. And you could also use pi r squared V1 equals pi r squared V2. Okay, one scenario and another scenario. Again, it's just conservation. It's very much like conservation of momentum, isn't it? Okay. Of course, the pies can cancel out, and you'll be getting some pie pretty soon for Thanksgiving. You take a look at this picture right here. You can see what happens to the pressure when we have a faster speed is the pressure gets lowered. This is what happens in a hurricane. When the speed gets faster and faster, actually the atmospheric pressure gets lower and lower because the particles are being pushed out faster and faster. Okay, so greater fluid flow speed, the lower the pressure. Okay, and then it finally brings us to Bernoulli's equation. Bernoulli's equation. You can see here is all of our equations. You can see the top equation is our equation for Pascal's principle. Then we have Archimedes' principle with the buoyancy. And then you can see we have the continuity equation. And then the last equation is Bernoulli's equation. Now it says P plus rho gy plus 1/2 rho v squared equals constant. When you see this equation, when you see Bernoulli's equation, I want you to take this equation and make it become this. Instead of using the y, use height. Okay? And instead of saying it equals constant, make it equal to each other. Now I hope you see this looks very similar to mgh plus 1/2 mv squared. Okay? It's ultimately energy with fluids. It's energy with fluids. So let me show you how to use this in a problem. Here we have a fountain. It has an opening of radius 0.01 meters. It shoots water directly vertically at 5 meters per second, and the first thing we want to find is our volume rate of flow. Okay, and so my volume rate of flow is of course my area times my velocity. My area of course is pi r squared. I have a circle times velocity, so I have pi, my radius 0.010 squared, and my velocity is of course 5 meters per second, and I end up getting for my volume rate of flow, ends up being 0.00157, and of course volume is meters cubed, rate is per seconds. And so that is the answer to A, my volume rate of flow. Now when we end up getting to B, we're going to take a look at the absolute pressure in the point. Okay, anytime you end up doing Bernoulli's here, and I'm going to erase this real quick and come back, anytime you end up doing Bernoulli's, I like to draw my picture right here. Okay, if you label everything, guys, Bernoulli's problems become so easy. So in class, on test, label everything. Here at this point right here, I'm at a height of 0, aren't I? I'm at the lowest point, so I'm going to call that 0. That's my frame of reference. It has a radius of 0.020 meters. That's what it said in the problem. It's fed by this change in the radius there. And I don't know what my velocity is. It's a big question mark. They didn't tell me. Now up here, at this point right here, which I'm going to call this point down here point A, and up here I'm going to call this point B. Okay, this is actually at a height of 2 meters, isn't it? Because the last one was 2 meters below, and so I'm going to call this 2 meters above there, okay, above 0. My velocity was of course 5 meters per second, and my radius was of course 0.1010 meters, okay? And you can see I need to find my velocity first, okay? So what am I going to do is use the continuity equation. A1v1 equals A2v2, and I'm going to call this side A, and I'm going to call this side B. And so I'm going to use pi r squared. This is at point A, which is 0.020 squared, and my velocity is, I don't know, that's what I'm trying to find. And I have pi, my radius is 0.010 squared, and my velocity is 5 meters per second, and I'm going to find my velocity. And so my velocity at point A, below the ground, ends up being 1.25 meters per second. Okay? When you do this, guys, you can cancel out the pi's there. And so right now, I'm going to come down here, I'm going to write in 1.25 meters per second, because that is what I know is my velocity at this point down here. Okay? Now, I'm going to just erase this. You can always rewind and come back to that. Okay? And now I'm going to go and do Bernoulli's principle. Now, Bernoulli's principle is pressure plus rho GH plus 1/2 rho V squared equals pressure plus rho GH plus 1/2 rho V squared. Okay? And so here we go. This is going to be side A over here. This is going to be side B over here. Okay, so now because I labeled everything, I know where everything goes. I'm trying to find the pressure at A. That's what I'm trying to find. So I'm just going to put P. I know my density of water is 1,000. I know my gravity is 9.8. And this is at a height of 0. Okay, so that cancels everything out there, which is nice. Okay, here I have 1/2, I have 1,000, and I know my velocity now, it's 1.25 squared. Okay, and when I calculate all of that, I get 781.25. Okay, now guys, this is the big point. Do you see how it said, I want to find absolute pressure? If I want to find absolute pressure, for this pressure right here, I want to put in 1 times 10 to the 5th. Okay? If I wanted to find gauge pressure, and I'll say this again, if I wanted to find gauge pressure, you do not need that pressure. That is 0 if it's gauge pressure. Again, this number right here would be 0 if I was using gauge pressure. Now I'm going to do rho GH. I have 1,000. Okay, and so 1,000 times gravity is 9.8. My height is 2. Okay, and let me fill in some numbers here. I have 1 times 10 to the 5th. If I do that calculation right there, I get 19600 plus, and I have 1/2 mv squared. 1/2, sorry, not mv squared. 1,000 v squared is 5 squared. Okay, and when I end up getting that, I end up getting 12500. Okay, now if you see, I'm going to add up all of these numbers, and I'm going to subtract the 781.25, and I end up finding the pressure absolute to be 131318.75 pascals. Now, of course, if I wanted to find gauge pressure, I would just subtract 1 times 10 to the 5th. I don't need that pressure, that absolute pressure there. Okay, but this is how you do Bernoulli's problems. How do you do Bernoulli's problems? Do A1v1 equals A2v2. Find all your velocities, find all your radiuses, find all your heights, okay? Label everything, and then all you have to do is plug it in. Bernoulli's equations. Guys, I hope this helped. I will see you in class. Take it easy.